you're predicting that by 2020, what did you say, 2030, that the engineering pool will be kind of small. There won't be as many engineers. Is that right?
Kind of tricky to predict. What we've seen is a lot of really brilliant technologists go into computer science these days. They don't go into hardware design as much as they used to, and their stats around that. And as demand grows, we're not seeing the supply of engineers also scale like that. It's not like universities see this coming and students see it coming and they see this rich career. It's true. This is what we're predicting, but people aren't going into the field. They're going into other areas of technology, and we're not producing anywhere near the new grads that we're going to need to keep up with demand over time. So that's a huge problem. That's why we need other ways. You can't just add people and meet demand. We need other ways of getting there.
Do you think that the AI improvements are maybe the culprit behind maybe the less engineers getting involved, or maybe less people being hired?
I don't think AI is a problem. I think it's just a lot of technologists gravitate more to software than they do to hardware. Hardware's hard. I don't know. I think that might be part of it. And also, I think it's a little less shiny. We're not as good at promoting ourselves, I think, as we see some other fields are, right? If you want to go into AI, you're probably going to go into a software side of it more so than try to train to become a hardware engineer at one of the AI companies. We just see a lot more of that. There's a big pull. There's a big pull toward sort of the computer science software kind of side, and not as big of a pull toward hardware design. There's a big call. If anyone wants to go into hardware design, there's a great career ahead of you, and there's going to be a shortage. But that's ultimately, one of the things driving the need for AI acceleration here is there aren't going to be enough people to do the work.
Totally. I'm kind of an old school engineer myself. I do things with like EagleCAD and KeyCAD or something like that, making little small circuits and stuff like that. So this stuff is a few steps above me. But I was thinking, if you did get into hardware, learning AI, the AI tools is probably essential, right, in this day and age.
Yeah, I think it's becoming a skill that everyone's going to need. Now, if we can make AI tools really easy to use, hardware engineers don't have to get good at AI. This is actually, one thing that we always did with Solido is we never wanted, our users to have to figure out what the random forest branching strategy should be for their model generation or something like that. It just automatically goes and does everything in the background. So you press go, just set it up just like you would a brute force tool, press go, and all the AI magic is completely behind the curtain. You can dig into it and learn more about it if you're interested, but most hardware engineers are too busy. So to me, the best AI acceleration for chip and board design is all going to be fully automated, where designers don't need to know anything, just they can do way more with way less, which is really cool. Another thing that AI is going to do here too is help newer designers to be able to do more complex tasks with less knowledge. So it's actually having a beneficial. I don't think AI is something that you have to learn. I think there might be some tools you learn to use, but I think it's going to have a much bigger benefit in being able to help you do more with less knowledge. I think cover more ground with less expertise, which is really neat.
I wonder if the software doing a lot of the work for the engineer makes it like a mystery, like a black box kind of thing. Like the engineer actually doesn't know what's happening. Like,
Yeah,
it'd be cool if the tools like also told you this is what I'm doing, explaining it to them,
for
perhaps.
a lot of things, I think the majority of tasks they need to. And because engineers are responsible for their chip working, if they say, "Hey, I made this design, here it is. I know this is going to work because I'm a good engineer." They have to be able to understand it and prove it, or they won't use it. And we went through that in the early days of Solido. We built tools that produced, some of our optimization technology, for example, would change your lengths and widths of your designs and show you that it's better. And I had people look at it and say, "That's cool, but I have no idea why that would be better. So I'm just not going to use that design." So you actually have to be able to explain, show your work. This is an engineering field. and you have to be able to show your work and prove that it's right. The cost of respins is very, very expensive right now too, tens of millions, even into the hundreds of millions for high volume consumer products on new processes. And so you don't want to make a mistake because you cut some corners and use an AI tool that got you a faster answer. You got to get the right answer. Your chip needs to work. That's really important.